We would like to welcome you. I guess since I am now working for the SETI Institute, I could do the introductions as well as anyone. I am David Morrison. I'm the director of the Carl Sagan Center at the SETI Institute, and I have been working perhaps longer than anyone else to protect the Earth from asteroids. In fact, NASA once gave me a medal for it. I started this business back in the late 1980s, and in particular was selected by NASA to be the chair of the first NASA panel that investigated the question of whether there really was an asteroid impact hazard. In those days, we had what we often called a giggle factor. No one took asteroids seriously. People didn't take impact seriously. Now, of course, we do, and you wouldn't be here if you didn't think that there was some interest beyond Hollywood in asteroid impacts and in defending our planet against them. Rusty Schweikart, Apollo astronaut, and very much a hero of all of us who are involved in the planetary defense, has really in the last 10 years focused a lot more power on this issue through his association with other space explorers, astronauts and cosmonauts, through the UN. He has become the primary spokesperson, not just for developing the technology of planetary defense, but perhaps more important, for making this an international issue and trying to understand what we would have to do if we discovered an asteroid on a collision course. Rusty, why don't you...
you can
and Phil Plait, on my left.
Yeah,
is a man who actually has managed to make money out of the issue.
Yeah, easier to
asteroids.
Easier to find asteroids if you can find the room you're supposed to be in when you're talking. Sorry.
Well, we were going on without you in the assumption that if we babbled on long enough.
Yeah, sorry about that.
So why don't you go ahead with a self-introduction, Phil, and then and Rusty, and then we'll do our introductory comments, but then we may have a moderator.
Yeah, we'll introduce the moderator.
Well, hi, I'm Phil Plait. I'm an astronomer, and the only reason I can think I'm up here is because I reviewed the movie Armageddon on my blog. I made fun of it. But I have written quite a bit about asteroids and mitigating asteroid impacts on my Bad Astronomy blog, and I've written about it it's the first chapter of my book, Death from the Skies, which I will be signing after this panel in the room next door. So
it's a fine book.
Just a little plug. It's,
Deeply discounted.
Yes, yeah. You said I've made money doing this, and it's like, yeah, that's true. I'm on the positive side, but the value of that, the how much on the positive side is up for grabs. As an astronomer as well, I've dealt with finding asteroids in the past. I've been interested in it. Years ago, I was hoping to get involved with a project to push some people to actually look for a 10th planet beyond Pluto, which I suppose would now be the 9th planet. Nobody.
That's the subject of another discussion.
Yeah, that's true. And I'm not at all irked by the fact that a couple of years later, Mike Brown actually found a planet or an object bigger than Pluto. He's here, not that would have been me, but it would have been cool to have been involved with that project, and nobody would take me seriously then. Now, we have hundreds of Kuiper Belt objects that have been found. But I'm fascinated by this topic, and I'm really interested in saving the world, just like Rusty is.
Rusty, why don't you kick off with not only a self-introduction, but go ahead with your prepared remarks.
Yeah, right.
Let's see.
Self-introduction. Okay, I born and raised, and then I flew Apollo 9, and here I am. Yeah, I as David and others know, I'm much more interested in what I am and have recently been doing than what I did back then. I mean, many people are interested in the old Apollo days, but for me, it's been there, done that. So the work that I've been doing, and David and a number of other people who work at the same McDonald's.
Can I ask, by the way, if you can hear all right? We need to
this
Move it closer, Hudson.
Yeah, let's just
down
use the
down.
mic.
Yeah. I don't know if there's somebody actually controlling these, but I know.
It's the moderator who isn't here.
Yeah, right. So I'll pull this one a little bit closer, I guess. So for the last 9 years, actually, I have been working this issue of near-Earth objects as a threat. Near-Earth objects are much more than that, of course. They're scientifically interesting subject or objects. They have a tremendous potential in the long term for providing resources for future space exploration, and for that matter, perhaps dwelling in space. They are certainly a subject of great interest here recently because of the new Obama administration space policy or space proposals, which since April the 1st have identified asteroid, a near-Earth asteroid, as the next target for human exploration. And they are, of course, also a threat in that they hit us from time to time, hence the title of the panel. Are we basically the next dinosaurs? And the really important point about, in case you didn't know, and I suspect 99% of you at least know this, but the answer to that question, are we the next dinosaurs, or are we the next group who's likely to go the way of the dinosaurs as a result of an impact, the answer to that is, interestingly, up to us. That is not the case with the dinosaurs. There is absolutely nothing the dinosaurs could have done which could have made a difference. We, on the other hand, now have evolved to the point where, in combination with the machines that we've developed, have the capability not only to know if we're being threatened and when specifically and by what, fairly specifically, but we literally have the technology today to do something about it, and for the most part, almost without exception, to stop what happened to the dinosaurs from happening with us. And our technology and capability is evolving so rapidly that in the time scales of the things we're talking about, that there's absolutely no question that within the next 20 or 30 years, it would be outrageous if, in fact, a life-threatening impact ever occurs again on planet Earth. Now, that's a pretty outrageous statement to make when you think about the fact that life-threatening events have been going on in the solar system here on Earth for 4.5 billion years, and I'm just saying that it's up to you, but we can stop that if we do it together. So the idea of human beings literally restructuring the solar system ever so slightly or ever so subtly, but nevertheless effectively, that we can now reduce the threat of accidents here affecting life on Earth. In other words, we now have within our capability the power to reshape the solar system to enhance the survival of life on Earth. Now that's a pretty outrageous claim, but it is nevertheless, I'll say true. That's a little extreme to say true. Anything is true in a scientific group, but you know, as close as scientists ever get to true, that is a true statement. So that to me is a subject of our discussion. It will be in much more detail with some graphics, which if you sit in the front row or two, you might be able to see the subject of a 3 o'clock presentation I'll make in a good bit more detail. But why don't I stop there, David?
Okay.
Has our moderator showed up yet?
No, I'm moderating until he gets here.
David, can I jump in for a second? The three of us were on the panel early this morning where we totally ignored the topic of the panel. And so...
Entertainingly.
It was a lot of fun. But in fact, the title of this panel is Asteroid Armageddon. Will the kind of rock that obliterated the dinosaurs get us next? And in fact, if we were to stick to that title, I would say no, because what wiped out the dinosaurs was a 6-mile wide metal-iron asteroid, nickel-iron asteroid. And there really aren't any large asteroids, that size at least, headed our way in the next, few hundred years that we know of. Barring the idea that there are comets that size, a comet like Hale-Bopp, which had a nucleus which was 30 kilometers across, which still terrifies me. That's almost 20 miles. And it was discovered 19 months before it passed the Earth. And if that had been aimed at us, we wouldn't be sitting here talking about it. We'd all be dead. That is a much larger impact event than what wiped out the dinosaurs. But it's not a nickel-iron asteroid. And I make that distinction because of what you said a second ago, Rusty. If we did see a 6-mile wide metal asteroid, or a comet even, we don't have right now in our quiver anything to do about it. We might in a few years. But even if we do, well, how much of a lead time would we need to prevent a literal dinosaur killer, a 10-kilometer asteroid, from hitting the Earth?
Well, if we were to see it, first of all, it would be extremely improbable, if not impossible, to have an asteroid of that size hit us by surprise. The likelihood, David, I don't know, it's pretty close to zero, the likelihood that there is, in fact, a near-Earth asteroid of 10 kilometers in diameter that has been undiscovered. Alan Harris posits about the only case I can think of where such an object could exist today and we haven't seen it, and that is one that has a period of exactly 1 year and is 180 degrees out of phase with the Earth from the sun. So
which is an unstable orbit.
In other words, the only way we could see it would be as if it's if we look right through the sun. And of course, as we say, it's not a stable orbit, and besides that, we couldn't see it. But things that large we see very easily. We essentially have 100% of the potential population of 10-kilometer diameter objects in our database right now.
Except for long period comets.
Now, okay, I said asteroid. Now, long period comets, that's a different thing, and frankly, my recommendation to everyone, 100%, with a long period comet heading for us, is get your martinis ready, get a great group of friends, go out into a nice spot where you can watch it hit. That's the best thing you can do. Long period comets, I don't even want to bother talking about. Maybe at some point in a quite distant future, we will have detection systems out in the outer solar system that will pick these things up and give us adequate warning where something could be done about them. But frankly, there's so much greater threat with near-Earth asteroids that I'll deal with the 99% plus issue and let the less than 1% issue for somebody else.
Rusty, I think maybe, I know a lot of you know a lot about this, and maybe it's worthwhile just to back off a minute and describe what the contemporary impact hazard is before we talk about what to do about it. So let me just do that quickly. There are 1 million near-Earth asteroids out there that are large enough to potentially do some damage if they hit the Earth. These are asteroids whose orbits cross or nearly cross the orbit of the Earth. They're not part of the main belt between Jupiter and Mars. They're generally much smaller, and their orbits bring them repeatedly close to the Earth and inner planets. Of those, anything larger than about 1 mile in diameter hitting the Earth would not cause a mass extinction, but it would really ruin your whole day, wherever it hit on the Earth. Because that's at the level you can throw up enough dust into the atmosphere to impact global agriculture and probably kill 1 billion people by starvation, by subsequent disease, disruption, all of these things. So as astronomers, we focused first on those objects a mile or larger in diameter. And we've been carrying out that survey now for a dozen years, with the idea that you can't do anything about it if you don't know where they are. So the astronomical approach, the so-called space guard survey, is to search with relatively small telescopes but very sophisticated data analysis techniques, find those objects one at a time, calculate their orbits, project them forward in time. And the good news, as Rusty said, is we have found nearly all of them larger than a mile, and not one of them is going to hit us. But really that shouldn't surprise us, because we're talking about a very low frequency event, something that has never happened in the history of humans on this planet, and probably wouldn't happen for another 500,000 years. But that's probabilities, and you have to weight the low probability against the terrible consequence if it did happen. And that's been our whole motivation. If you played the odds, you wouldn't bother with this, because we're unlikely to have a big asteroid come along in our lifetime or our grandchildren's lifetime. But it's stupid not to spend a few $1 million to find out whether, in fact, there's nothing headed for us. And policymakers will certainly tell you that they aren't interested in 1 in a million or 1 in 10 million chance, but they're damned interested if we could come up by finding an actual object that was on an impact trajectory. Now, that's for the big ones. The other issue that we will probably turn to later has nothing to do with avoiding mass extinctions or even avoiding a global catastrophe. But what happens if we find a smaller object that's on a collision course? That's much more likely. There are many, many more small objects than big ones. And that is a different kind of policy question. Maybe it wouldn't be big enough to do a lot of damage. Maybe it would be aimed for the ocean and not do any damage at all. But now we're talking about something that is reasonable to imagine in you or your children or your grandchildren's lifetime. And so you've gone down a whole other policy track in thinking how you would defend against an object 30, 40, 50 meters across, something basically the size of the Santa Clara Convention Center. And so, so we've focused on the big ones, and we still have to worry about that a little bit, but increasingly the issue will be on the more frequent, smaller events. And the other thing that I know Rusty will go into is simply that you find these objects, you track their orbit. You're talking about maybe an impact 50 years from now, but you don't know the orbit exactly. And for every object that actually hits, there will be 50 or 100 cases that look scary for a while. And that, again, is a public policy issue. Even if we think we're not going to be hit by anything, even a small one in the next century, we are going to have some close calls. And I'm sure Rusty will talk about that too. So that's just a quick background. Let me ask Phil before we go back to Rusty, because you deal more with the public than we do, actually. What do people think about this issue? Are they afraid of asteroids? Are they afraid of these little ones that might do much more than just make a real bright flash in the sky? Where do you come with the public on these issues?
That's a good question, and I'm not sure exactly how to answer it, because there's a big old selection effect plopped down right in the middle of that, and that is that
Make it up.
Yeah, I'll make it up. They're terrified of this, and they just want to open up their wallets and dump out money at our feet. No, there's a little bit of an effect here, because the people who are emailing me are the people who are worried enough about it in the first place. There are certainly any number of documentaries on History Channel, Discovery Channel, Nat Geo, talking about this, and they almost routinely get it wrong. It's actually astonishing. As Rusty and I were talking about it earlier, and he'll mention later, they tend to ignore the idea of the keyhole, which is extremely important. And what I've noticed is that they love talking about doom and gloom, and then spend 1 minute at the end going, and if we send a rocket to him, hit him, we'll push him out of the way, and then we'll be fine. And then that's it. And because I can't resist self-promotion, I have a TV show that'll be airing soon on Discovery Channel. It's a pilot right now for a show. But the whole first episode is called Bad Universe. If you go on YouTube, you'll find the trailer. The whole first episode is on this topic, and the whole episode is about what do? We characterize what asteroids and comets are, and we talk about how we can keep them from impacting. So it's a slightly different take on this issue in that it's reality-based. But I think ever since '98, when Armageddon and Deep Impact both came out in the summer, and they were both, I think they were #1 or #2 at the box office, people took it more seriously, which is distressing that a movie like Armageddon would actually, put the fear of this into people.
As I mentioned this morning, Armageddon has been used within NASA training to see how many errors can be found in the film.
Yeah.
And I'm told the number is 155, but I haven't been able to bear to watch it all the way through to count it.
I suspect that's an order of magnitude too small. I think there are that many errors in the last scene when they blow it up. I show a 3-minute clip when I give talks, or 2 minutes, and it's just I can't even keep track of what's going on. But I think people know about this. I think they're aware of it. I think if you were to poll the American public, which is always an interesting endeavor, you will find that most of them know, for example, that the dinosaurs were wiped out by an asteroid. But I don't think they grasp this. And I tell people, have you seen the movie Trinity and Beyond, the atomic bomb movie? Not too many people have seen it. This is a fantastic documentary. The guy took all of the nuclear weapon footage from history and cleaned it up and set it to music, and it's a documentary. It's brilliantly done. It's terrifying. And every single explosion in that movie is smaller than what you would expect from a 100-meter wide chunk of iron hitting the Earth. The largest nuclear weapon ever detonated was 50 megatons by the Soviet Union in the 1950s. And that would be a smaller detonation than the energy released by a 100-meter impact. So, anytime you've ever seen a nuclear weapon detonated in footage, imagine that going off somewhere on Earth 5 to 10 times in one spot. And that's what you get from an asteroid that we have a 50-50 chance of having, a week's notice before it hits us. And that is what terrifies me. That is what...
You were going to explain why this doom and gloom is exaggerated, right?
Yeah, exactly. But that's my point, right? For a 100-meter wide asteroid, there is a chance we wouldn't see. Well, 100 meters we have a good chance, but it's 140, right? Is sort of the size limit that NASA wants to find. And 100 meters there's a decent chance that 100-meter asteroids we would not see before an impact. Or at least only have a few days warning.
Within the next 10 years, yeah.
Yes. And so, that's scary. And that's what I want to tell people about. This is real, and it's something we should be concerned about. It's not something that I lie awake panicked about. I don't want people to be, because I know I get email from kids and they're terrified by this. And I say, don't be terrified by it, but be concerned, because this is a real worry, but it's also something that we can handle. It's something we can do something about.
So, Rusty, what are we going to do? What are we doing about it, or what should we do about it?
Well, there's a lot to say on the subject, obviously. Let me try to give a couple of snapshots. First of all, to get a picture of the deflection challenge as separate from the sort of actuarial issue of what's the probability of getting hit. I mean, they're related, but they're two very different things. And I'll try to give you a good, simple picture of it. Picture standing at home plate with your eyes shut and a bunch of yo-yo kids with strong arms at second base are throwing rocks at your head. Okay? Before you open your eyes, you either get hit in the head and die, or they all miss you and you live. And that's what we've been doing. Now you squint one eye open a little bit and you say, oh, hey, there are things flying past my head. Maybe I ought to start looking so that I can duck if one's headed for me. And you realize that, in fact, you're seeing some of them only at the very last minute. In other words, you don't have your eyes open wide enough. Okay? So as you open your eyes wider and wider, you see these rocks coming at you, and you're picking them up a little bit further and further away. That's our bigger and bigger telescopes. Now, what do you do as an individual? What you do is you look, and if something looks like it's heading for your head, you duck. Automatically, even if you don't want to, you do it. You duck. However, the reality is, if you close your eye, 90% of the things you duck for probably wouldn't hit you anyway, at least if the kids are throwing the rocks fast enough, okay? In other words, you cannot wait until you have 100% certainty that something's going to hit you before you duck, because you're dead. You can't react fast enough. So what you're going to do in that situation is you're going to duck 10 times, 40 times more often than if you didn't do anything. If you just close your eyes, you'd get hit in the head. That's our exact situation with near-Earth objects. You have to act before you know for certain that you're going to get hit, because if you wait until you know, it's too late. You don't have enough time to prepare the vehicle, launch it, do the rendezvous, blah, blah, blah.
And I would intersperse that until 10, 15 years ago, we had our eyes closed.
Yeah,
we had no idea.
And at the moment, we got our eyes sort of halfway open, right? Because we know the biggest ones, but we don't know the far more frequent smaller ones that are coming at us. But the main point I wanted to make in this is that there's a big difference between the actuarial issue of what are the number of objects out there and how frequently does the Earth get hit by each size and all of that, and the geopolitical challenge of making a decision to duck. You will duck automatically when something's headed at your head.
If you see it.
You don't, yeah, if you see it. You don't even make a conscious choice, you're going to duck. It's called survival. But when it comes to the action that we're talking about, you're talking about the world, the international community, making a collective survival decision to deflect an asteroid, the equivalent of ducking. And that's the real problem here. The technical problem of finding them that Dave and Clark Chapman and a few other people started back in the 90s, that is a technical issue of finding them. And as Don Yeomans at JPL says, the three most important things about surviving the asteroid impact threat are find them early, and find them early, okay? And he's right. But there's a fourth one that's right behind those three, and that's have something to do about it, okay? Now, having something to do about it, we've got. Come to my lecture at 3 o'clock and you'll get a little bit more on that, but not a lot. I mean, frankly, the technology of deflecting them is pretty straightforward. All you gotta do is change the velocity 10 years or 15 years ahead of an impact, very, very slightly, and it's not gonna hit. Now, you want to do that in a controlled way because you don't want it just to miss, but we're going to figure out eventually. We want it to miss in a very specific way. Okay, so you need both a robust capability like run into it, a collision, kinetic impact, and some kind of a precise way to do it. And I would propose we have one at hand now, which is called gravity tractor. Okay. The real issue is the third element, not just finding them, the early warning and having something to do about it, but the geopolitical decision that's got to be made. Somebody's got to make a decision. We do something, this is what we do, this is who does it, this is how we handle liability if something goes wrong, this is how we pay for it, etc. That geopolitical decision is the reason why we're probably going to get hit before we're ready. Because we're going to procrastinate. We're going to do the standard political number, and we'll just procrastinate until it's too late to duck. Hopefully, that one will not hit us in the head, but will hit us in the ocean. But that'll wake everybody up. So I'm going to stop there. We can go to questions or whatever you want to do, Dave.
Well, a couple more things. Even if you're worried about small ones.
Oh, by the way, I should have, pardon me, let me just finish my thought. I should have said something. If you look at the actuarial probability of getting hit by the smallest thing, therefore the most populous, the most frequent thing that can hurt is probably 30 to 40 meters in diameter. Depends a little bit on what it's made. My friend over here likes metal, nickel, iron things, but it doesn't matter much what they're made of. So if you say 300 years is the frequency with which you get hit, 200 to 300 years, and if you have to duck 50 times more frequently than you would actually get hit if you didn't duck, now you're saying every 4 years the world is going to have to make a decision. That's a serious issue for politicians. Every 4 years we're going to be faced, on average, with a decision, do we or do we not duck? And you know what? We're going to go up there. The worst part about this is we're going to go up there. In other words, we're going to duck. We're going to send something up there. When we get there, we're going to realize, because we have a transponder now, which gives you much more accurate tracking, this one wasn't going to hit. And the whole world is going to say, ah, crying wolf. And
The British term is they got their sums wrong.
Yeah, that's right. The British press will say they got their sums wrong. Again, those dumb astronomers, right? So the point is, this is a very, very challenging geopolitical, social issue, because we're going to have to make decisions very frequently when what we do after we make the decision is realize that we didn't have to duck. And boy, that's going to be a real twisted lesson.
Let's talk for a minute about a slightly different kind of decision. The technology exists to deflect an asteroid, but we've never done it. We've never tested it. It's not cheap. It might cost us several $1 billion just to even demonstrate a simple ability to go up with a spacecraft and change the orbit slightly. Are we justified in doing that without a specific threat to deal with? And I'd like to ask both of you to comment on that. Should we go to the president and say, we would like $1 billion a year for the next 10 years to develop a technology that we may not need for centuries?
That's another good question. I might argue we have done it once with the Deep Impact mission, but that was just a few hundred pounds of copper slamming into a comet, and the exchange of momentum was so small, I don't know if we could measure it, especially with the comet, which is extremely difficult to measure their exact trajectory, if we did anything to it. With an asteroid.
Can you remind them what the Deep Impact was?
Yeah, I'm sorry, Deep Impact was a mission in 2005, which took an
4th of July.
Yeah, it was the 4th of July. I actually observed it. It was pretty cool. An 800-pound chunk of copper slammed into a comet. Copper was used because we're pretty sure there's no copper on a comet. And so when we observed the explosion, you could look and see what was comet and what was copper, and you could distinguish them, and we could say, okay, here's what happened with the comet. It was a wildly successful mission in that, you're basically, you've got a comet moving at several miles per second, and a rocket, or a spacecraft moving at several miles per second, and you don't know exactly how big the solid part of the comet is, you don't know exactly where it is, and they were able to home in on it and smack it and hit it, and it was terrific. So we sort of kind of have that technology, but that was a small piece, something this big or so. We're talking about, you'd want something that is much larger than that if you want to actually change the trajectory of a large rock. You want to be moving as quickly as possible to maximize the whack, the kinetic part of that impact. So we've tested it once. We have sent probes to other planets, so we have kind of an idea how to do this. But that's it. We don't know what would happen, and it depends on the kind of rock. If you're talking about something that's a solid piece of rock versus something that's a rubble pile, the impact might behave differently. If you hit it on the edge, you might shear off a piece of it and lose a lot of your energy, and it's something we have to do. And I don't know. I mean, we're having a hard enough time figuring out what the heck kind of rocket we're going to build over the next 10 years. And that's, we got to decide what rocket system we're going to have to even do that. So I think right now the political situation's a mess.
David, my answer is absolutely unequivocal. Yes, we spend the money to do it, and the second thing I would say is I think you're way overestimating the cost. But that's a matter for future debate. And I think that the cost is an important issue. It's not the most important issue, but it is an important issue, simply because if it costs next to nothing, of course you'd do it. I mean, that becomes very obvious. Let me just say why I don't think it costs you anywhere near that much. A kinetic impact is, as Phil said, challenging from the standpoint of guidance and control, because even though you can run into a comet that's relatively large, we're talking about running into a much smaller asteroid that may be, again, the size of the convention center out back here, rolled up in a ball. So it's a little more accuracy you need. You want to have a reasonably high velocity, but that's not all that important. The guidance issue is there. And that's a pretty dumb thing. The Deep Impact mission, which included 2 spacecraft, really, one that separated from the hunk of copper and went out to the side and took pictures of the impact. So it was a good bit more complicated. With the kinetic impactor that you'd want to use to deflect an asteroid, you just run the whole spacecraft right into it. You'd have a separate spacecraft which would be observing, and it would probably have been up there ahead of time and measured the orbit precisely. But that mission is probably, even today with inflation, $250 to $300 million. It's not very sophisticated. The other spacecraft that you want to observe it, we would have, again, not very big. It's probably about 1 metric ton, 2,000 pounds, something like that. And that kind of a spacecraft is a gravity tractor that would also observe it, and then afterward pull it around a little bit using gravity as a tow rope. Again, that's your typical scientific spacecraft with some additional software in it and ion engines, which you can move out 60 degrees or so. So that's probably 5 or 10% more than a typical scientific spacecraft of, say, $350 million. So that's the kind of money you're talking, testing this in my idea for under $1 billion. That's not a big deal. We launch 5 times that many spacecraft every year. And not only that, but a lot of that you can write off for science. We're going to send missions to asteroids anyway. That observer spacecraft can have a lot of instruments on it, and even after the impact with by the kinetic impactor, you can do a science mission. So who knows? The science community is going to say, no, you can't write off anything, but I'm going to say that the science portion of that is worth at least half of the cost of the mission. So, it's a matter of allocating the funds.
Right,
okay.
And by the way, there has been a significant change in the last year, and Rusty's part of that. He's now a co-chair of an official group within the NASA advisory structure that is dealing with what's sometimes called planetary defense. The president has himself said that he thinks that is a significant role for NASA. And that's all new. 2 or 3 years ago, that wasn't the case. But can we get...
Wait, let me finish.
Okay.
The most important reason to do it, that was not the least important, but that was not the most important reason to do it, to demonstrate that we can do it. The real reason to demonstrate it is not because it's cheap. The real reason to demonstrate it is that you do not want to have the world public aware that there is a threat, which, as we just said a few minutes ago, is going to happen once we've got our inventory up every 4, 5, 10, 15, 20 years, something like that. You do not want to have the world public in a position of thinking they're all going to die, and everybody's going to think they're the ones who are going to die, of course, if there's a threat impact, using the technology to deflect it for the first time then, when we could have demonstrated it for as little as $1 billion, 1% of the NASA budget for 1 year.
But it would really be exciting that the public would follow that mission.
Sure, the public, yeah, involved in the mission, but you're going to have I mean, you know, if you have a capability to avoid a very serious threat, then politically you want to do it unless the cost is exorbitant. You want to demonstrate that capability because you don't want public. I mean, Phil and I already get emails from not just kids, I get them from mothers. Too.
Yeah.
In fact, I get them more, I think, from parents than I do from the kids. Some people are petrified. Well, that's no threat. When we have a real threat, I mean, a genuine threat, even though it's 1 in 1,000 probability or something, I mean, it's a serious issue, and you want to be able to say, yes, it's a serious issue, and we have demonstrated and proven a capability to deflect it.
Come hear Rusty's talk later today, but let's, for the last 15 minutes hear from you and your questions.
Hi, I'm a high school science teacher, earth science specifically, and my students do a project towards the end of the school semester. And a number of them have chosen near-Earth asteroid and impact. What I would like to know, I know that the near site from NASA dealing with near-Earth asteroids. Is there a place where dealing with what to do about this? Does that goes beyond? Because I know you just mentioned something that you said Rusty was involved with some project now or something.
B612 Foundation.
Here's the question for everyone: is there a resource that you can go to on the web or whatever that really talks about the action that we would want to take? Not the nature of the threat, not the astronomical observations, but the actual defense problem.
Yeah, and that is b612foundation.org, b612foundation, all one word, .org.
It's the asteroid from the Little Prince.
Right, the Little Prince came from the asteroid B612, so he was our hero. Now, I'm going to make a statement that's even more outrageous than the one I made earlier about no asteroid should hit the Earth again because of our capability. I'm going to tell you right now, and I'm angry about this. I've been angry about it. It's a ridiculous, stupid thing to be able to say truthfully, and that is that I'm the world's expert on deflecting asteroids. That's absolutely outrageous, inexcusable. Luckily, it's about to change, I think. But that is an absolutely unbelievable, stupid thing to be able to say is true.
Another way of phrasing that is no one is being paid in the world to do this.
We have avoided this issue officially. Not only have we avoided this issue, we have proactively, and when I say we, in this case, I'm saying NASA and the US government has proactively acted against addressing this issue up until just now. And so things are about to change, and for the first time in this whole area, with this issue, when you ask me, can you do something about this, I can tell you yes, because very shortly it's going to come down to a line item in a NASA budget and a few other agencies of the government that say we ought to be spending a very, very small amount, frankly, but nevertheless real money that's earmarked, pardon me, I don't want to use that, that's identified for this activity.
Okay.
Yeah, just kind of a follow-up on the expert over here. Seriously, what about the other powers, the Japanese Space Agency, the European Space Agency, the Chinese Space Agency, the Russian Space Agency? I mean, there's everybody else, and there's other folks in the game other than us. And what has been their kind of position on this particular issue?
Right. Excellent question, because it is a global issue. It's not a national issue. You can't.
And that was the question. What do other agencies do? What is their attitude? It's not just NASA.
Everybody has basically been avoiding this, but that's changed. In the last 5 years, the Association of Space Explorers, which is the professional organization of astronauts and cosmonauts from around the world, have taken on the geopolitical element of this NEO issue. That is, we have, as the Association of Space Explorers, and I headed the committee, we have taken this into the United Nations, into the Committee for the Peaceful Uses of Outer Space, or affectionately known as the Outer Space Committee of the United Nations. And the United Nations, and it's a long story, I'm not going to bother telling you, I got a report up here I can show you, but we have now taken this to a set of recommendations of what has to be done, not how it's going to be done, but what has to be done by the international community to be prepared to make a timely decision when there's a threat. It's got to be cooperatively done. The United Nations has now taken ownership of that set of recommendations and that issue, and there has been one international workshop so far, January in Mexico City, dealing with the informational and analytical aspects of the issue. And in October of this year, we are bringing together for the first time the official representatives from the spacefaring nations of the world to have a workshop on the mission planning and operations elements of this. In other words, we're now at the holding international workshops to implement the recommendations so that the world will be ready. And in that, we're talking the United States, Russia, the European Space Agency, JAXA, the Japanese Space Agency, and the Chinese National Space Agency. And who did I miss? Somebody.
Canada?
No. India. And India. So the 6 nations which are capable of launching satellites are going to be officially meeting in Darmstadt, Germany in late October of this year for the first time.
Okay, let's take another question back there.
I understand Russia is very interested in this problem also. Between us and them, there are probably more nuclear bombs than necessary. What's the possibility of using some of these nuclear bombs to deflect an asteroid?
Yeah, the question is that there are more than enough nuclear bombs in the world. We could spare a few if it would protect us from asteroids. Phil, do you want to comment on that?
Actually, I think Rusty is probably more of an expert
Well,
on
we have
this.
the expert.
From what I've been able to learn, I just know that nuclear weapons are not a good idea to try to disintegrate them. You'd rather use it to blow up nearby and then vaporize part of the material and use that as a rocket to push it away. But even that's not really as effective or as easy as just whacking it really hard.
And also, who's ever going to let us test a nuclear system?
Right now, it's illegal to blow up nuclear weapons in space.
Not
Well,
quite.
yeah, I've had
Not
this discussion
quite.
with other people.
Not
Yeah,
quite.
not exactly. That's
It's
sort of
weapons of mass destruction.
glossing over it, yeah.
Well, it's a good question, and frankly, because of Armageddon and Deep Impact, in large part, actually, and in small part, because we call it planetary defense, and so the automatic assumption is Defense Department, and automatically Defense Department means the biggest bang you got, okay? And besides that, Americans like big bang, right? So there's a lot of sort of default momentum in the culture, which assumes the way you deal with this is with a nuclear weapon. The fundamental position, without elaborating, and we can talk about it privately if you'd like, but the fundamental situation right now is that for 98% or so of the threat, it would be unnecessary to utilize a nuclear explosion as the means of deflecting. But there are still remaining, at the moment, about a 2% situation where you might have to, where the deflection requirement is greater than the capability of either one or more kinetic impacts. And so at the moment, we cannot rule out the possibility of having to use a nuclear explosion. It is a bit more robust than a kinetic impact, but as Dave says, it's very difficult to stomach the idea in the world community of of testing this. I mean, who's going to, oh yeah, U.S. Defense Department, yeah, you're going to save our butts. Thanks a lot. I mean, there's not a lot of trust out there in the world of the U.S. and the U.S. Defense Department, you know, taking over and you all sit back and we'll save you. Now, the one thing just before we leave that, let me just say, I said at the moment, and the reason I say at the moment is that as we observe more and more, as we get more and more of these rocks into our inventory, as we discover more and more, what happens is the ones that remain end up, it's obvious when you think about it, you discover the biggest ones first. And coincidentally, it's the biggest ones which you would have to use a nuclear weapon for. So within another 10 or 15 years, we're going to have almost 100% inventory of things down to about 300 meters in diameter. And below that, the kinetic impact is good enough. So over time, we're going to find that we don't need to have a nuclear weapon standing by for this purpose.
Over here.
All right. Say there's an asteroid coming and they need to deflect it. Whose craft are they going to send up? If there's an asteroid aimed at Moscow, I don't think they trust the Americans.
Yeah, that's, I don't know, people probably couldn't hear that. It is absolutely excellent question, great example. The young man says, okay, there's an asteroid headed for an impact with Moscow. He doesn't think that the Russians would trust the Americans to deflect it. And that is exactly why we're dealing with the United Nations, because what we want to do is end up with a set of policies which is based on hypotheticals, which is based on a generic impact, and I'm going to say a word about that in a moment, but not one that you know where it's headed. In other words, what are the criteria that we use? How do we decide, regardless of where it's going to hit, who should deflect it? Do we draw short straws among the spacefaring nations? Do we sell it, you know, do we assign it to the lowest bidder or maybe the highest bidder? Do we go alphabetical order? Do we do a cooperative project, you know, and try to come up, you know, each bearing some of the cost? That question of who does it and what technologies are acceptable to the world is why we're having the meetings in the United Nations that we are. Now, the saving grace to some extent in this is that we will not know before a deflection has to be launched whether it's going to hit Moscow or Berlin or Paris or the middle of the Atlantic Ocean or Washington, D.C. The line will go all the way across the Earth still, in all likelihood, at the time we have to decide to launch. And you're not going to know who along that line is actually going to get hit until you get up there with a transponder which shortens that line until it's just a few hundred miles long or something. So in general, we're going to have to take action before we know not only who is going to get hit, but even if the Earth is going to get hit. And that's the dilemma.
And come back at 3, and I'm sure Andy will show you some of those slides. We have time for 1 or 2 more questions, yes?
I had a question. In case an asteroid was deflected and it was a very close miss of the Earth, extremely close, would there be any effect environmentally? Any dramatic effect of Earth rotation, etc.?
Right. The question is a near miss. Are we really safe from a near miss, or could it do damage? And I think the answer is clearly, it has to touch you to hurt you. It's not, these things are so tiny compared to the Earth. They have no effect on tides or orbits or spin or any of those things. And incidentally, we will have such a thing happen. On Friday, April 13th, 2029, a 300-meter, 400-meter long asteroid called Apophis is going to come extremely close to the Earth, inside the area of our geosynchronous satellites. You'll be able to look up, if you're in Europe, and watch it with your naked eye going past. That's the closest anything's ever come, and that's not going to be a danger. That is going to be fun. We hope to instrument it, you know, with scientific instruments and so forth, and actually get a very close look at this object. Let's do one more question. Yes, sir.
Let's assume you have a 500-meter object approaching. How soon can you see it in terms of days, weeks, months? And how long would it take you, given present technology, to get to it?
Let me start that. The question is the 500-meter object, for instance, how far in advance will you see it? Well, what you have to think about is the time, not the distance. Because remember, these asteroids have orbits that bring them past the Earth over and over. And the object that's going to hit will have come by thousands of times. So the issue is not that you're seeing it on approach, but a long way away. You see it on some previous orbit. And so that's the whole philosophy of these surveys. You're not looking for something at the last minute. You're looking for something in which you can have years or preferably decades of warning. And with a 500-meter object, we're going to find all of them within a few years. And so we'll have, centuries of warning for every single one, and we hope none will have our name on it. Gentlemen, let's get concluding comments from both of you, and then we'll let the good folks leave.
Something I just looked up here while we were talking. Rusty, you said that a mission to kinetically impact an asteroid would cost under $1 billion, you think? The combined worldwide gross for a deep impact and Armageddon together was $900 million. I will leave you with that to ponder.
And they didn't even do it
the
right.
The box office ticket sales. The box office ticket sales of those two movies combined was $900 million.
Rusty, you have the last word.
Well, I don't. My last word will come at the end of my presentation in an hour. So for those who are interested in the subject, and it is a fascinating subject, and a very real one, as I say, because of the change, the recent change of administration, there is some new thinking going on, and in very short order here, finally, we are beginning to take official public government, in other words, responsibility for this issue of public safety. And I, for one, am very delighted that Dave started this back in the 90s, and that we've been able to do a lot in the intervening 15 or 20 years.
Thank you all for coming.